Tell me one thing. While we are discussing about regression analysis, we looked at the concept of R square. We looked at the concept of adjusted R squared and the interpretation of it. We looked at the concept of p-value, the formula, and the interpretation of it. We looked at the concept of VI of the formula and the interpretation of it. We practiced all these concepts in Python. Let's say tomorrow you join a company. There the client is asking you to work on SAS. What are you going to say? No, I have worked on regression only in Python. SAS, I don't have any idea. I'll not be able to do regression. Is that what you're going to say? Do you think from Python to SAS, the meaning of R square, the interpretation of R square, does it change?
No.
The formula of p-value, the interpretation of p-value, does it change?
No.
The step-by-step process that we have followed, is that going to change from Python to SAS to R?
No.
Or SPSS, whichever? Let's say you have to work on a totally different language altogether. Do you think you have to learn from the beginning once again, or the tool doesn't even matter? Only the concept matters. What do you think? In future, if you are facing an interview, if the client is asking you, or if the recruiter is asking you, you have worked on Python, we are going to work on SAS here, we are going to work on R here. What will be your answer? Will you say that, no, sorry, I don't know regression at all on Python? Is that going to be your answer? Or are you going to say, I have practiced in Python, I know regression very well, I just need to learn the syntax of SAS, I'll be able to handle? Can you say that?
Yes, sir.
I just need to learn the syntax of R, I'll be able to handle it. Because what really matters, the conceptual understanding is what matters. Yes or no? Does the tool really matter? Are we really writing a lot of code here, or are we simply calling the functions? Even in Python, we did not write a lot of code, isn't it? We simply call the relevant functions, and that's what happens everywhere. Maybe here you wrote some kind of function. In SAS, you will be calling procreg. In R, you will be writing a different syntax. From tool to tool, these concepts will remain the same. Only syntax is different. What I'm saying is you should be open-minded to work on any tool in future. Can you do that? Everyone, can you confidently say that no matter which programming language that I have to work on, I can do my regression modeling? Can you say that confidently, everybody? Since you know this process, all that you need to do is what? Only learn the syntax of that particular tool, isn't it? And then once you get the results, the interpretation will remain the same. Even within a tool also, let's say within Python, right now we have used stats models package. Maybe there is another package called Scikit-Learn package. Even if you have to work on a different package, from package to package, again, what will be the difference? If you have two packages doing the same thing, what will be the main difference? Do you think these concepts will be different? Formulas will be different? No. What will be different? Syntax will be slightly different. So the point that I'm trying to drive here is, whichever tool that you're going to work on, you should be open-minded. You have to accept with both the hands and say that, yes, I will be able to work on any tool because I have the conceptual knowledge. Are you with me, everyone? Are you also as confident as I'm saying right now? Can you say that?
Yes.
That is very important, because in some of our interviews, we are seeing that some of the students are saying that, sorry, I know only SAS and Python. I don't know R. Sorry, I cannot do machine learning and all that. Now, that's not the right answer, isn't it? What you should say, yes, I have never worked on this tool called R, but I'll be able to pick it up because the important concept is with me. I just need to learn the syntax. Any questions on that? Anybody? Any doubts in that?
No.
Now, what we will do is, within Python, we will try to use a different package. Let us see what happens if you are changing the tool or a package. Let's take a simple example, X versus Y. Based on the age, you would like to see whether a customer has bought the product. Okay. X versus Y, you want to build a regression model. Earlier, we have built the regression model already, but we have used a package called stats models until now. What I'm saying is, if you change the package, nothing will be different conceptually. If you are using Scikit-Learn package, what will be difference? Only the syntax. Let's say now if I'm using a different package altogether called Scikit-Learn, so import the package. There's a slight difference in the way that we are importing the package. We have to follow that syntax. Earlier, we used to define model. Now you say my model name is LR equal to linear regression, or model equal to linear regression. Then model.fit, supply the values of X, supply the values of Y. If you remember, previously it was opposite. Earlier, in the earlier package, we used to write Y tilde X1 plus X2 plus X3 and so on plus XK. Now we have to write X1 plus X2 plus and so on plus XK, comma Y. This is the syntax defined by stats models. We have to follow that when we are using it. This is the syntax defined by Scikit-Learn. We have to follow that syntax when we are using it. But the rest of the things would be same. That means the meaning of beta coefficient will be same here. Beta coefficients will be same here. Earlier, we used to write model.summary to get a detailed summary of the output. But here there is no such function as summary in Scikit-Learn. That was one of the reasons why initially I have used stats models. But still you can get it. What you have to write model.intercept. Then you will get the intercept value. Model.coefficient. Then you will get the coefficient value. Model dot some matrix dot r square. Then you will get the r square value. Model dot predict, supply the values of x. Then you will get the y value. So basically, to generate the same summary, you will be writing more lines of code here, but the results would be same. Do you think the r square value here would be different from the r square value here?
No, sir.
Do you think that will be different in SAS? That will be different in R? That will be different in IBM, SPSS, something like that? Given the data set, R square formula is same. If the mathematical formula is same, then no matter which language you're using, it is not going to be different. Are you comfortable with this, all of you? Any tool that you're going to use, you should become, because as a concept, machine learning concept, you know it, the tool can be anything. So let us do a quick recap of regression. All of you open the logistic regression code file. If anybody has already the code file link, put it in the chat window. I'll also open it from here. Then let us quickly recap regression with a different package altogether. Here is the code file. A couple of people have already pasted it. Let me take this. So what I want you to do is import the packages, import the data set, build a regression model. Once you build the regression model, then give me the predicted values using that regression model. When age of the customer is 4, what is the predicted value? When age of the customer is 105, what is the predicted value? Give me the predicted values for these two data points. Execute until model prediction and give me the predicted values. When age is 4, what is the predicted value? Minus 0.0866. Verify that, confirm that, somebody else. When age is 105, what is the predicted value? 2.028. Check these. Are these the numbers that you are also getting?
Yes, sir.
Right. Once you have both these numbers, give me a quick confirmation in the chat window. If everybody is on the same page, we will get started. All of us. Now focus on this, all of you. Whatever you're doing, just stop it and look at this. Your data set has two columns. What is the first column? It's a simple data set. The first column is age of the customer. The second column is whether the customer will buy the product or not. Age can be 20, 30, 40, 50, 60, 70, whatever is the age. The target variable, this is X. The target variable Y takes only two values, 0 or 1, 0 or 1. Some zeros, some ones. 0 means the customer is not buying the product. 1 means the customer is buying the product, or the vice versa. A customer is not buying the product, 0. 1 means the customer is buying the product. These are the only two values that we have in the target variable. Now, when the value or the age value of X is 4, what is the predicted value? Minus 0.0866. What does that mean? Is he buying the product? Is he not buying the product?
Is not buying.
Historically, were there any negative values in the data set? Have we ever seen any negative value?
No.
There were no negative values. Is it fair to assume that negative means not buying only? Negative was never defined, isn't it? So historically, when there were no negative values, we cannot think that since it is near to 0, this must be C. 0 means not buying, 1 means buying. Negative, we do not know. What exactly is that? So there is something wrong with this prediction. Something wrong. You have class 0, you have class 1. Is there anything like class 2 historically? No. When age is 105, the predicted value is 2.02. Can I assume that this person is buying 2 items? Was there ever a 2 defined historically?
Not defined.
Not defined. So we cannot assume anything. This is also something wrong with this. There is something wrong that's going on in the backend. Either the answer should be either 0 or 1, but the answers, the predicted values are coming out to be minus 0.0866, 2.028, which means there is something wrong that's going on. Let us investigate further. Look at this. If you investigate further, what you will feel is, if you try to draw this on a graph, this is how it will appear. On x-axis, you have age. Age can be 4 years, 5 years, 10 years, 20 years, 15, 20, 40, 50, 60, 70, 80, 90, and so on. On the y-axis, you have the target variable, which takes how many values? Zeros and ones. 0 means not buying the product. 1 means buying the product. There's nothing like 0.82, 0.61, 0.42, 0.25, 0.13. There's nothing like that. Either 0 or 1. The whole data is concentrated either at 0 or at 1. When the data is like this, for this data, what did we do? We built a what? A linear regression line. We built this one. Yes or no? Linear means a straight line. This is a straight line only. Yes or no? Or can it be a curvy line? Can this be a curvy line? Is this the
No.
equation of a curvy line? No. It will always end up like a straight line only. And for this data, we are actually building a linear or a straight line regression. Is it possible for this straight line to go through almost all the points in the data?
No.
Is it possible, no matter what optimization you apply, no matter what technique you apply, can this straight line represent our data? Can this straight line go through almost all our points in our data?
No.
No.
Can I say linear regression fails here?
Yes.
Linear stands for
Yes.
straight line. Straight line regression fails here. Linear
Yes.
regression is not a silver bullet that it will work on any type of data. That's not true, isn't it? There are some places where linear regression definitely fails. This is one such example. What are the other examples? In sales, you're trying to predict whether a customer is buying a product or whether he's not buying a product. Based on what? Based on the customer age, based on the customer income, based on the customer number of dependents, based on the customer expenses, based on the customer profile details, you're going to predict whether the customer is going to buy or not buy. Even same thing in marketing, you're going to predict whether the customer will respond or not respond based on the customer profile details. Because India is a huge country. Crores and crores of people are there. A lot of people use mobile phone. I cannot keep on calling everybody. Before making a call, I have to make sure that whether the customer is going to respond or not respond. If there's a high chance for the customer to respond, then only I'll try to make him a call. Then only I'll try to sell him my insurance. Yes or no? In credit cards and loans, before giving a loan, I would like to predict customer will be a defaulter or non-defaulter, bad or good customer, based on the customer income, based on the customer number of loans, based on the customer monthly utilization, based on the customer number of late payments, etc., etc. Based on all these factors, financial historical data, I would like to predict the customer will be ending up defaulter or non-defaulter. In operations, based on the customer usage data, based on the customer number of complaints, etc., I would like to predict whether the customer will be attrited or whether the customer will be retained, whether the customer will stay back based on the customer usage. In the websites, for example, based on the number of visits you have made to a particular website, based on the number of pages that you have seen, based on the content that you have browsed, what type of websites that you're visiting, what type of posts that you're sharing on social media, how much time you're spending on news websites, how much time you're spending on certain type of articles. Based on the complete clickstream data, we are tracking you. From past 6 months, we are looking at the complete web browsing history based on what purchases you have made on Amazon, based on what purchases you have made on Flipkart. We have been tracking you completely. Based on all of that, we are going to predict whether you are going to click on this ad or whether you're not going to click on this ad. If you're not going to click on an ad which says that from India to UK, cheap flight fares, I know that you're not going to click on it. Then why would I show that to you? Last week, you were searching for a mobile phone. I would rather show a mobile phone than a flight ticket. But for somebody else who was searching for a flight booking, I would like to show him that that advertisement, isn't it? So whether the customer will click or not click. In fraud identification, if you swipe the card once, we can get hell lot of information. At what time are you swiping? 3 a.m. in the morning or 5 p.m. in the evening? What is the vendor that you're swiping? Where are you swiping this? Is it at an international airport or is it a local grocery store? What is the amount that you have swiped? Is it very different from the usual amount that you swipe? What is the number of transactions you have made on a given day? Is it like suddenly spiked up? Usually you tend to swipe 2-3 times, but this one day itself you swipe 30 times. Is there anything wrong there? Where are you swiping and how much is the amount? How many number of transactions? Based on one swipe, we can get hell lot of information. Based on all of that, I would like to predict whether transaction is fraudulent or non-fraudulent. In healthcare, you're predicting whether you can cure it or not cure it. In fact, 90% of the business problems, 90% of the business problems are framed as classification problems. These are all called as classification problems where you're trying to predict the output will be either 0 or 1 either this side or that side, responder, not responder, good or bad customer, attrition or non-attrition, fraud or non-fraud, cure or no cure, etc., etc. Until now, we discussed regression problems. What are regression problems? Where the output is continuous, where you are predicting sales, continuous output. Yes or no? Where you're predicting number of users, continuous output, number of passengers, continuous output. When the output is continuous, those type of problems are known as regression problems. When the output is categorical like this, either this side or that side, 0 or 1, in those cases, these are called classification problems. What happens is most of the business problems are classification problems only that we come across in day-to-day life. For all those classification problems, can you use linear regression? Can you use a straight line? A straight
No, sir.
line will definitely fail. We have to look for curvy. What is those curvy called? Non-linear. Have you heard of this term? Non-linear. What do you mean by non-linear? It means it is not a straight line. So there are several non-linear functions, but our data is in a particular format. How is our data? Either it is at 0 or is it at 1. So for our data, which non-linear function suits best? Which non-linear function in these examples suits best for our data?
Logistic.
You take double exponential, it covers one side, but it misses the other side. So this cannot be used. Logistic is the best one for our type of classification problems. Logistic regression or logistic function is the best suitable. In fact, the best part is max value it takes is 1, min value it takes is 0. Our data is also at 0 and 1 only. And it has a linear tails also. That is also even more helpful. So instead of building a linear regression line, linear regression suits for this type of data. Instead of building linear regression line whose equation is y equal to beta naught plus beta 1x, we will be building this line. This is known as logistic regression line. This is known as logistic regression line. Now, there must be an equation like this way. This forms a straight line. There is an equation for this one as well. The equation is y equal to e power beta naught plus beta 1x divided by 1 plus e power beta naught plus. This is the logistic regression line equation. Like the way this forms a straight line, this will form an S curve like this. Here also, what are we finding? If you are building a logistic regression line, here also you are finding beta naught, beta 1. Here also they are known as intercept and coefficient of x. But however, the way you write the equation is very different. When you write this equation, it will end up an S curve like this, which is a perfect fit for our classification problems. Okay. So the previous problem that we have built a linear regression based on age. You're predicting whether the customer will buy a product or not. Instead of building a linear regression line, we must be building a logistic regression line there. All that we need to do is we have to tell Python that do not build a linear regression line using the syntax. So here is the difference in the syntax. Earlier, we have mentioned my model is equal to linear regression here. Now, once you mention my model is equal to logistic regression, then internally y equal to e power divided by 1 plus e power, that will be formed. Then once you say model dot fit, then beta naught, beta 1 values will be calculated. Everything will be stored in this model object. Then you can get the output logistic dot coefficient, then that will be beta 1. Then you will get logistic dot intercept, that will be beta naught. Then you are ready to use that. Then you say model dot predict. Now, if you supply the age 1, which is 4 years, then you will get the predicted value accurately because you're building the right model. If you supply the second one, then you will get the predicted values accurately. So the major point that I'm trying to tell you here is linear regression may not work everywhere. There are some cases, in fact, 90% of the cases in this world are classification problems. For those classification problems, you will be using this logistic regression to solve it. Go ahead, execute this part of the code and tell me what are the updated predicted values now with logistic regression. What is the predicted value when age is 4?
0.
Predicted value is 0 when age is 105. 1. So whatever is the definition of 0, whatever is the definition of 1, you can think of that as the predicted value. Have you got the updated values, all of you?
Yes, sir.
Now look at this. One common question that arises in our mind is, in which situation I should use linear regression? In which situation I should use logistic regression? I have a data set with me. How do I know when to use which model? That's a common question that comes to our mind, isn't it? When we hear any new technique, the first question that comes to our mind is when to use which technique, when to use which machine learning algorithm. What did we do here in this particular example? We first started with, okay, let's go ahead with linear regression. Then we saw that there is something wrong with the predictions. Then we started investigation. Then we started drawing the data. After drawing the data, we realized that no, this is not a linear regression problem. It's a classification problem. That's why we have to build a logistic regression. Yes or no? That's what the approach that we have followed. Tell me honestly, in the real world scenarios, is drawing the data possible? Real world scenario, do you have only X and Y variables, just 2 variables, or you have so many variables? In the real projects that you're doing, there will be so many variables. Is it possible to draw the data and check? No, it's not possible. So this is how you have to decide this. You have to look at the problem statement. You have to look at the problem statement, understand it carefully. And you also look at the target variable. You look at the problem statement, you look at the target variable carefully. Based on this, you should develop the intuition to find out whether it is a regression case or whether it is a classification case. Whether it is regression or classification, you can decide that by looking at the problem statement and the target variable. And it's not very difficult. Let me give you a couple of problem statements and ask you whether it's a regression problem or a classification problem. So what we are going to do is we are going to do an interactive activity right now. All of you, please go on mute, go to your chat window, put number 1 and write down what type of problem is it, a regression problem or a classification problem. Go ahead. Everybody must participate in this. So put number 1 and write down whether it's a regression problem or a classification problem. Number 1 is regression problem, no doubt about it. Number 2, put number 2, is it a regression problem or a classification problem? Number 2. Number 1 is regression problem, there's no doubt about it. Predicting the loss percentage can be 1%, 2%, 3%, 4%, 50%. It's a continuous output. This is a classification problem. Predicting number of customers, number 3. A lot of you are not typing it. I want everybody to participate it. Even though you feel it's very easy, very simple, but still. Number 4, problem number 4. Problem number 5. Problem number 5. The number also, so that I get to know what are you talking about. Regression. Problem number 6. Number 6 is regression. Number 7. Classification. Number 8. Classification. Number 9, fraud application. Predicting fraud or non-fraud. Classification. Problem number 10. Amount of, this is also fraud, this is also fraud. Though both of them are the same application, but the technique that we use second time would be regression. Can you tell me, write down your project ID and tell me whether it is a regression problem or a classification problem based on your target variable, whatever you're predicting. Write down your project ID and tell me whether it's a regression problem or a classification problem based on what you're predicting. Most of you must be predicting whether the customer will be ending up like a good customer or a bad customer, which is like a classification problem, isn't it? 1D is a classification problem that a lot of us are doing. Yeah. Classification. Have you seen most of the problems in the world are classification problems? If you see these two examples, you can predict whether a given a transaction is fraudulent or non-fraudulent. You can also predict exact amount of fraud, which is like $1, $2, $10, $50, or $100, or $2,000, or $1 million. But if you have two choices like this, if you have two choices like this, whether you can predict whether it is a fraudulent or non-fraudulent versus the amount of fraud. Okay, amount of fraud. What do you think companies would be mostly interested in? They are interested in classifying it as fraudulent or non-fraudulent. That is more priority, or finding out the exact amount of fraud. That is the more priority. Which one is a priority item for companies?
Classification.
No matter how much small, even it is $2 fraud, that is considered very seriously. Yes or no? What's the reason for it? It's a security breach. So I don't really care about amount. That is secondary. For me, overall fraudulent or non-fraudulent, finding out whether it is yes or no answer, that is very much important. In future, no matter what problem statement comes to you, will you be able to look at the problem statement and the target variable, decide it as a regression problem or a classification problem? Can you do that? Have you got the confidence now?
Yes, sir. Yes, sir.
Any questions on this, anybody? Any questions on whatever we have discussed until now? Right? Is it clear? Now, when we were doing regression, there's a step-by-step process. Similarly, in logistic regression also, you have multiple logistic regression, and there is a step-by-step process that we have to follow. So what is multiple logistic regression line equation? When you are predicting the target variable y, whether the customer will end up like a bad customer or a good customer, it's not just one factor like age. It's age, number of loans, monthly utilization, number of late payments in the last 3 months, last 6 months, etc., etc. There are several variables that will impact the target variable. The real world is multivariate. Multiple variables will impact the target variable y. Again, there's a step-by-step process in logistic regression that we have to follow to build this model. As usual, we have to take a case study, and then based on that case study, we will understand all these theoretical concepts. The case study that we are taking here is one of the most common case study that you will see in multiple companies. Even when you join a company, there's a high chance that you may be working on a data set like this. So pay a lot of attention on this. This particular model is known as churn prediction model, customer churn prediction. Have you ever heard of customer churn prediction? What exactly it means? For example, in a particular region, there are 10,000 customers. Okay. Out of those 10,000 customers, these customer churn prediction models, what they try to do is they try to predict and tell, okay, these 8,500 customers are going to stay back. These 1,500 customers are going to churn out. Okay. These 8,500 customers are going to stay back. 1,500 customers are going to churn out. That's what, like right now, these are all active, by the way. The churn prediction model will predict this.
What is churn, sir?
Churn means, let's say a customer is leaving. Let us suppose you are using Airtel from past 2 years. Okay. Now you churned out. You were a customer to them. You churned out. That means you moved to Jio. Okay. That means churn. It is also known as attrition. Have you ever heard of attrition or churn, or in simple words, leaving out? Okay. Customer churned out, gone out, chhod ke chala gaya types. Okay. So basically, out of these 10,000 customers, this model will predict that these 8,500 customers are going to stay back. These 1,500 customers are going to leave in near future. Leaving is known as churning out. Clear? Now, what is the use of such prediction? If you think of it, anybody, what is the use of such prediction? Right now, all of them are active, right? Why should I be worried? What can we do?
To prevent the churning out numbers.
We
To
can
decrease.
prevent the churning out numbers, isn't it? What we can do is, to prevent these churning out numbers, we apply strategies to retain them. These are known as retention strategies. Try to retain them by giving them some offers. Try to retain them. Like, have you ever got a message which says, use this coupon code, come back? You have waived off 1 month late fees, come back. Sometimes you might have got some offers which are exclusive for you. The company or the service or the product just wants you to come back. Those are known as retention offers, because companies believe that getting a new customer, the cost is twice or thrice compared to retaining an old customer. Do you know that? Retaining an old customer is easy compared to getting a new customer, and onboarding him takes much more cost for us. Now, what do we do with these 8,500 customers? They are going to stay back. So for these 8,500 customers, we're going to apply cross-selling and upselling strategies. A cross-selling strategy is, if the customer is already taking product or service A, we try to sell him B or C or D, because he's going to stay back. He's a loyal customer to us. Let's say a customer has a savings bank account with us and he's very loyal. What do we do from our bank? We try to sell him our bank insurance. We try to sell him a loan. We try to sell him a credit card.
We give him some benefits.
We try to give him not benefits. We try to make it look like a benefit, but we try to sell another product. What is number one rule in marketing? Never give any benefit to loyal customers. Okay? Never ever do that mistake. Are you getting it? It sounds counterintuitive, but that's number one rule. Tell me why. Why you should not give any free offer to a loyal customer?
They're anyways going to say.
Because the return on investment will be zero, because you don't need to really attract them with any benefits or anything, because they're always anyway loyal. Okay, that will be a loss. You put that money here, then you will get a better return. Okay, never ever give free stuff to loyal customers. Never ever. Okay, but make it look like a benefit, but always make sure that we are squeezing them. That is called cross-selling. Have you got the hang of cross-selling, all of you? What is cross-selling? If you go to MACD, if you ask for a burger, what they will say? Let me make it a meal. Yes or no? That is called cross-selling. What is upselling? If a customer has A, he is not trying to take these three, then we will push him into upselling. Yeah, you're not buying any product. Let me put you to 2A, 3A, 4A. I try to make more benefit out of the plan that you have. What do you mean by that? Let's say if you are using an internet connection of 20 Mbps, what I'll ask you, to take my TV, but they are not taking the TV connection. What do? Upgrade it to 50 Mbps, 100 Mbps, like that. So this is called cross-selling, upselling. Those are applied on the loyal customers. Retention offers are applied on this. Behind cross-selling, upselling, retention offers, behind all these marketing strategies, there is a clear science. There is a lot of analytics that goes on behind the scenes. The messages that we are getting, they are not random messages. All this analysis is done in the backend. Have you now got a hang of what are we going to do with this churn prediction? Do you think every customer facing company have to do all this? Isn't it? They also like have to go through all this. Who's the customer who's going to churn out, find out, and try to do these retention offers. We are going to build one such customer churn prediction model now. Have you understood the problem statement, everyone? Business background. This particular data set has been shared by one internet service provider company. I have anonymized the name. And what did I do before bringing the data here? Since we are focusing only on model building, I have taken care of the data cleaning part. This particular data has been tracked, like this internet service provider company has tracked 1 lakh customers, good amount of customers, 1 lakh customers for 2 years. At the end of 2 years, some customers are active, some customers are inactive. Who are these inactive guys? These are the guys who churned out at the end of 2 years. These are the guys who are still active. Now that is my target. And what are the other factors that I'm also tracking? I'm also tracking how many complaints they have raised. I'm also tracking number of times they have changed their plan, whether they have relocated or not, what is their monthly bill, whether there are any technical issues or not, all those things. What is the months on network, age of the customer on our network, all those I'm tracking. Now the idea is, this is the historical data that you have. You build a model on this data. Now, why do you use this model? Already you know who is the active customer, who is the churn out customer. Already you know that, right? Actual values are in front of you. Why do you even need this model? It's already happened, right? Those who are going, they're already gone. Those who are active, they're already active. Why do you build a model like this then? Tell me.
Just the pattern.
What we do is, the main crux of machine learning is understand the patterns from the historical data. Then what do? We apply this model on the new customers. That means if you have taken this data on a region 1, you take this and apply it on region 2 where everybody is active. On that, you just, like right now, everybody is active in a particular region. You apply this model there. What will happen? You supply the values of X. Then we will get to know who is going to be churn out, who is going to be active, and we will filter out all the customers who's going to churn out. Then we apply certain strategies to retain them. So the data set that we have has these variables. The first variable is the target variable, whether the customer is active or inactive. Income, months on network, number of complaints. Do you think number of complaints has anything to do with customer attrition?
Maybe we have to check the data.
Number of complaints, if like in general, what happens if customer is giving more and more complaints? That is an indication that there's a high chance that the customer is going to churn out, right? Like at least the logically it says that it must be there. A customer is frequently changing his service plans. Too many times he's changing the plans. What does that mean? is not satisfied with the service plan that we are giving them. A customer relocated. This is internet service provider. It's not mobile. Do you think relocation plays a big role in internet service? Yeah.
Yes.
Yeah. Monthly bill, technical issues per month, speed. Does speed play a role? We are
Yes,
promising
sir.
certain speed, but the customer is not getting that then also. So on the face of it, looks like all these variables are somewhat relevant to the target variable. Now you have two models, linear regression, logistic regression. When you are solving this problem, which model are you going to build?
Regression.
Regression, without any doubt. Is it linear regression that we are going to build?
Logistic regression.
Logistic.
The target variable is taking only two values, zeros and ones. It has to be logistic regression. Do you really need to build a linear regression and see that it is failing? Then only you will come to logistic regression, or directly can we go to logistic regression?
Directly.
Directly, we don't need to fail and come here. It's very straightforward. So directly we build a logistic regression line. Let us have a look at the syntax here. The syntax is my model is equal to logistic regression. My model dot fit, supply the value of x1, x2, x3, and so on, xk. I'm supplying all the variables. Is it a literal summation? No, it's a way to tell Python that these are all the variables that I'm using, comma, the target variable y. This is the target variable. Finally, we have to give the target variable. Okay. Once you say model.fit, what will be the result? Then logistic regression model will be built. What do you mean by building the model? The values of beta naught, beta 1, beta 2, and so on, beta k values will be calculated. What do you mean by model building? Whether it is linear regression or logistic regression, model building is nothing but finding the values of betas. But as I told you earlier, model building is considered as only half of the job. As a good data scientist, you should never think that you're done with everything just after model building. Model building must be followed by
Model validation.
Validation.
model validation. Earlier in linear regression, what was the model validation measure that we have
R-square.
used?
R-square.
R-square. Since the data format, since the target variable has changed, R-square directly doesn't work here. We have to think of a new validation measure. Let me show you the new validation measure for a classification problem. So what you do, you try to take the data that is given to you. In our data set, as usual, you have x1, x2, x3, and so on, xk. You have the target variable y, which is known as y actual. What are the actual values? Sometimes 0, sometimes 1, zeros and ones. Do you already have the model now? Yes, I do. I have the model. So what we will do with the model, supply the values of x to the model, use model.predict function. Have you used model.predict function already? Model.predict function to get the predicted values of y. Y predict. So for the first row, the predicted value of y is, let's say 0, 0, 1, 0, 1, 1, 0, 1. These are the actual values. These are the predicted values. Once you have the actuals and predictions, you know what you will do? You create a matrix out of this. You write y actual here, y predicted here, y actual and y predicted. Y actual values are zeros and ones. Y predicted values are also zeros and ones. Y actuals are zeros and ones. Y predictions are zeros and ones. Imagine this itself is your data set, full data. How many times the actual class was 0? That was also predicted as 0. How many times
1.
it happened? Actual class was 0 and it has been predicted as 0. Overall, how
1.
many times? Only once it happened.
4.
0 predicted as 0.
4 times.
4 times.
0 predicted as 0. 0 predicted as 0. 0 predicted. It happened 4 times, right? How many times 1 has been predicted as 1?
4 again.
4 times.
1, 2, 3, 4. Now these are right predictions by the model, isn't it? Model is doing a good job here. Actual was 0, prediction is also 0. Actual was 1, prediction is also 1. Very good. But how many mistakes it is making? How many times 0 has been predicted as 1 wrongly?
1 time.
Once.
1 time.
There is an instance where 0 has been predicted as 1. How many times 1 has been predicted as 0?
Once.
Well, that is also an error. That is also a mistake. Okay. So once it happened. Overall, how many predictions your model has made? How many data points are there total in this data set? Overall, 10 data points. Out of 10 predictions your model has made, how many instances it has predicted accurately?
8.
8. It will be model
0.8.
accuracy is 80%. So this is the matrix that will help you to validate whether a model is doing a good job or not. This matrix that is given here is known as confusion matrix. What is it? Confusion matrix. From this confusion matrix, you have to derive the accuracy. How do you derive accuracy? Sum of the diagonal element, 0, 0 element, 1, 1 element divided by overall summation. That is how you find out whether the model is, how accurate the model is. Once again, how many times 0 has been predicted as 0? How many times 1 has been predicted as 1? These are right predictions. These are wrong predictions. Sometimes 0 is known as class positive. 1 is known as class negative. Positive, negative. Predicting positive as positive is known as true positive count. True negative count. Actual positive, but falsely predicted as negative. False negative count. Falsely predicted as positive. False positive count. No matter what you are terming, easy one would be predicting 0 as 0, 1 as 1. And these are wrong predictions. This confusion matrix and the accuracy derived out of it will tell you how accurate your model is. Go ahead, build the model, calculate the accuracy. Tell me what is the accuracy value. For your model that you have built, what's the accuracy that you got?
.85.
85%. Is that correct? Verify. Anybody else? Roughly 85% is the accuracy. While executing the code, you may get a warning. That is just a warning. You can ignore that warning. You can carry on. Even with that, the model will be built. 85% is the accuracy of the model. Check this out, all of you. Now, there was a concept called multicollinearity. Tell me, what was multicollinearity? We discussed this in the context of regression. What is multicollinearity?
Interdependence of features.
Dependency of
So we
variables.
discussed that in linear regression, when you're trying to predict target variable y using x1, x2, x3, x4, and so on, xk, interdependency of the features is known as multicollinearity. Two or more features related to each other is known as multicollinearity. Try to prepare a detailed answer for it. When somebody asks you an interview question like this, the concepts that you know, which you are very, very confident of, try not to give a one-line answer to that. Try to give a very detailed answer so that the other person knows that the clarity that you have in the overall concept behind it. So when we are trying to predict target variable y, these are the features, and the interdependency between the features is known as multicollinearity. The problem is the beta coefficient, you cannot trust them if you have multicollinearity present. Now come to logistic regression. Here also we are predicting target variable y using x1, x2, and so on, xk. But what is the difference? Earlier the target variable y was continuous. Here the target variable is classification 0 or 1 types. But the system of x variables is almost the same. Is it fair to say like that? Earlier also the x variable was age, utilization, etc., etc. Here also x variables are like this only. The system of x variables did not change much. So the problem that we used to have earlier, the interdependency between features, is also a problem here. Even in logistic regression, interdependency is a problem. Even in logistic regression, if two or more variables are connected to each other, if both of them are giving the same information, then it's a problem for sure. Okay, even in logistic regression. So multicollinearity is an issue even in logistic regression. That means the beta coefficients that you are getting, even in logistic regression, you will be having wrong coefficients if you have multicollinearity, because multicollinearity is not connected to target variable. Multicollinearity is connected to only features. It is not connected to target. Okay. But there is a lucky point here. What is the lucky point? The methodology that we have used earlier to detect multicollinearity, the same methodology can be used here. What was the measure that we have used to detect multicollinearity?
VIF.
We have used VIF for detecting multicollinearity. The same concept of VIF can be used here. Based on VIF, how are we picking and choosing? If VIF is greater than or equal to 5, then we know that there is some multicollinearity. The same approach can be used here. Why can we use the same approach? Why is changing, right? But still I'm using the same approach. Can you explain me why it works?
Sir, because the independent variables are same.
We are treating with only multicollinearity is all about the features. Now, when you're working with only features, what happens in the target doesn't really matter. Multicollinearity can be, it's a problem here in logistic regression as well, common problem, but you can use the same technique of VIF for detecting. Initially, you have started with how many variables? X1, X2, and so on, X8. 8 variables are there. Between them, there can be multicollinearity. You start with 8 variables. Check the VIF values and let me know if there's any variable that has VIF more than 5. Go ahead.
No, sir.
2 variables.
Sir, number plan and technical issues.
2 variables have VIF more than 5. Tell me number of plan changes.
And technical issues per month.
Number of plan changes, which is how much VIF?
11.4.
11.98.
1.4.
11.98. And what is the other one?
Technical issues.
Technical issues per month. What is the VIF?
11.4.
So you have 8 variables. 2 variables have VIF more than 5. We will drop both the variables. We will be left with 6 variables. Is that what we are going to do?
No.
No, sir.
No, we are not going to do that. Which variable are we going to drop?
Number of plan changes.
We are going to drop the variable that has the highest VIF. We are going to drop this. That will leave you with 7 variables. Do we need to check VIF again in these 7 variables, or is it okay?
We need to check.
We need to
Check,
check.
sir.
We cannot be 100% sure. Go ahead, check the VIF in these 7 variables and let me know.
They're less than 5.
All of the variables are having VIF less than 5. That means all of them are independent. If you take any xi versus xj, definitely they carry independent information. No 2 variables carry the same information. Everything has its own information. Does that mean all these 7 variables are impactful on target variable y? They will definitely be creating an impact on the target variable y. Can we give that guarantee by looking at VIF?
No.
No.
VIF tells what story? Between x, whether there is any relation or not. Does it tell anything that x versus y relation?
No.
Now, how do you get to know whether a variable is impactful on the target variable or not?
P.
By looking at the p
value.
value. So previously also we have seen a p value for individual impact of the variables. We check the p value in linear regression. Behind the scenes, there is something called t-test that is done that will end up in p value. Behind the scenes here, some z-test is done that will end up in p value, but the interpretation of the p value remains the same. Exact the theory behind the p value, I haven't yet explained it to you. To explain that theory, we will wait for some more sessions. Then finally, I'll come to this. But the interpretation of the p value will be same. So how do you interpret the p value? You calculate the p value of each and every variable xi, and then what do you say? If
Less than 0.05.
the p value is less than 0.05,
It
then
is impactful.
that feature is
Impactful.
impactful. If it is greater than or equal to 0.05, that feature is
Not impact.
Not impactful.
Okay. Now you started with 8 features. Based on VIF, you are left with 7 features. Okay. Based on VIF, you're left with 7 features. Are you going to check the p-value again in 8 features, or anyway we dropped 1 feature, we have to check the p-value in 7 features? What do we
7
need to do?
features. 7 features.
Since you have
7.
anyway dropped it, there is no need to go back. You check the p-value among these 7 features and tell me whether there's any feature that has p-value more than 0.05.
It's a monthly bill.
3 bill has a p-value of how much?
0.307.
0.307, which is greater than 0.05 for sure. We can drop this. So you're finally left with how many features? 6 features. These 6 features, all of them are independent. All of them are impactful. That is the rule. The rule is all the features that you're going to have in your model at the end, they have to be independent, they have to be impactful. Okay. These are the 6 features that we finally use. There is one more additional extra analysis that we can give to our client apart from whatever we have done until now. It was not possible in linear regression, but in logistic regression, you can give one extra analysis. Right now, these x1, x2, x3, x4, x5, x6 are impactful. I agree. What you can say is out of these 6, x4 is the top most impactful, followed by x1, that is the next most. Out of these 6, these are the top most impactful features on the target variable y. All of them are impactful, but the maximum impact is by x4, next maximum is x1. You can rank order those features. You can tell the client to focus on these features. Let's say if you improve everything, overall the service will improve, overall the attrition or the churn will reduce. But if you have limited budget, if the client asks you what are the points which I need to focus mostly on, then you can rank order the features. You can tell them you focus on x4 first, you focus on x1 next. How do you rank order the features and tell out of all the impactful, which one is the most impactful? You can rank order the features based on a statistical measure called world chi-square value. Based on the world chi-square value, if this world chi-square value is high, that means the feature is mostly impactful. Sometimes the impact is positive, sometimes the impact is negative. That direction doesn't matter. Whether the impact is high or low, that matters. That is given by world chi-square value. But in the Python output, world chi-square value is not directly given to you. So based on the Z value, you can estimate the world chi-square value by taking the square of it. You can estimate it. You look at the Z square value, that will give you the world chi-square value. Higher the Z square value, higher the impact of that variable. That means you have 6 variables. If I ask you what is the top most impactful variable, top 1, which one is that?
Number of complaints.
Number of complaints. Check the Z value, all of you. Let me wait. All of you check that out. Somebody else also confirm that to me.
Yes, number of complaints.
Number of complaints
Number of complaints.
as the topmost. So if I have to focus on one point, yes, I can improve everything else. But what is the most important thing I have to improve to reduce the attrition of the customers? I make sure that I'm addressing this complaints issue. I make sure that
Yes.
I increase the number of field engineers. I make sure that if a complaint is raised, previously we were taking 48 hours. What we should do now? We should take only 24 hours or 12 hours. Yeah. So that the number of complaints are reduced, so that the attrition is reduced. Obviously, this decision will be taken by the business, but we are giving them some kind of insights from our analysis. What is the next factor that I have to focus, if at all I have to
Speed.
focus on?
Speed.
Is it like speed test result? Is that correct? Somebody else confirm that to me.
Yes, speed.
Yes, sir.
Speed. That means a lot of complaints are coming with speed. Maybe if you think that already you're providing good speed, but people are not realizing it, maybe run an ad campaign which says that we are tested by UCLA, we are the fastest network, etc. Somehow put some focus on speed, somehow put some focus on number of complaints. Then you will have highest impact on the Y variable quickly, because these are the top 2 most impactful variables. This is not really mandatory. This is an optional step. This kind of step was not possible in linear regression, but here in Logistation, you can give this extra output to the client. So once again, what are all the steps that you have to follow while you're building the logistic regression line? Let us recap them. First thing, in which situation do you even come to logistic regression line?
Classification problems.
When the
Classi-
problem type is, when the output is classification or a class variable. It is not continuous. Okay, you decided that this is a case of logistic regression. We should be going for a classification model. You have decided that. And then what is the next step? You build the model, build the logistic regression line. While you are building the first logistic regression line, are you going to select few variables and then build the model only with them, or try to use all the features?
For all the variables.
All the
All
variables.
the features. Because we have to give a chance to every feature once. That is model building. Once you're done with model building, you must follow that up with
Confusion
Validation.
matrix validation.
model validation. So how do you validate the model? What is the model validation metric?
Confusion matrix.
Confusion matrix.
Yes.
And then from there you derive accuracy. Okay. Next one. Once you're done with that, let's say accuracy is above 80%, you're satisfied with that, you proceed. Is it possible that in the first go itself you will get 80% accuracy always for every data set?
No, not
No.
mandatory.
In practical scenarios, you may get sometimes 65 or 70. Okay. Later on, you will do few more things to improve this accuracy. Next one,
VIF,
you check the
checking for the variable.
VIF. What does VIF do? What is the use of VIF?
Check the interdependency between
It will check the
features.
interdependency, which is also known as
Multicollinearity.
multicollinearity. VIF will check the multicollinearity and tell you whether there are features that are interdependent. So based on what you will select VIF,
Less than
less
five.
than
Less than five.
less than
five,
5, that
sorry.
feature is
Is independent.
Independent.
Then
More than 5 is dependent.
keep or drop.
We should keep the independent one.
This
Dependent.
is dependent. Then
Drop.
Drop.
But dropping, drop all
No,
One by one.
One
One
with
by-
highest
Sequential.
VIF.
sequentially, the highest one. Then the next step is
P-value.
look at the
Right.
p-value. What does p-value tell you?
Impact.
Whether
Impact.
feature is impactful or not. How do you select based on p-value?
Less than 0.0.
Less than
Then
0.05.
0.05, that feature is
Impactful.
Impactful.
impactful. Then
Keep.
greater than or equal to 0.05, that feature is
Not
Non-
not impactful.
Drop.
Drop that. There's one extra step, additional step that we have. What is it?
Z value.
We can look at the walled chi-square value. What is the use of it? To rank order.
the impactfulness of the variable.
Rank order the impactful features. First 5 are mandatory steps. The last step is optional step while you are building the logistic regression model. Are you comfortable on all these steps, everyone?
Yes, sir.
Yes, sir.
That completes logistic regression.